Welcome to this video. In this video, we want to learn how to balance chemical equations. And in particular, we'll use two examples to demonstrate the steps that you need to do to balance the chemical equations. Please, before we can even look at the two examples, don't forget to subscribe to our YouTube channel. That is Zuluba Consultants, and the Facebook page for this and more videos. If you find this video very beneficial, don't forget to like it, to share this video, and give us a comment on how best you have enjoyed the video. So let us look at the steps that one needs to do regarding balancing chemical equations. Remember, we are going to do two examples, so finish the whole video. The first thing that you need to do when it comes to balancing equations is to list down the atoms that are in the equation. So in this equation, we have the left side and the right side. Now, on the left side, you can see that we have hydrogens and nitrogen. Even this side, we have hydrogen and nitrogen. So, how many hydrogens do we have? On the left side, we have 2 hydrogens, then 2 nitrogen. On the right side, we have 3 hydrogens and 1 nitrogen. So after you list down these atoms, you notice that some of the atoms are not balancing. So look at those atoms that are not balancing. In this case, both of the atoms, that is hydrogen and nitrogen, are not balancing. We have 2 hydrogens, 3 hydrogens, 2 nitrogen, 1 nitrogen. Now, if you notice that the 2 are not balancing, what can you do? Well, the first thing you can do is to try to swap the even and odd numbers. So try to swap the even and odd numbers. What do we mean? When you look at hydrogen, we have 2 here and 3 here. So try to swap. These 3, you multiply it here, then these 2, you multiply it here. What do you get? You have 6. You also have 6. Now, what does this mean? These values you have used as the multiplying factors tentatively becomes the numbers you put on the main equation. So for hydrogen, we are saying try to put the number 3 there. Then for the product, because it's 1, these 2 will be tentatively put there. Now, once you do this, so we have introduced this number and this number in our equation. Once you do this, you look at what this introduction has resulted into. You will notice that for hydrogen, it has resulted in us having 6 hydrogens on the left side and 6 hydrogens on the right side. So hydrogens are balanced. Let's look at now nitrogens. For nitrogens, on the left side we have 2, on the right side we have 2 also. So now it simply means there is this multiplying factor which has affected nitrogen. So now write the equation that reflects that the atoms have balanced. So the equation that is reflecting a balanced equation will be 3H2 plus N2, giving us 2NH3. So you notice that we have 6 molecules, 6 atoms of hydrogen, 6 atoms of hydrogens, 2 nitrogens, 2 nitrogens. So this is what we do when balancing. Let's look at the next example. The second example that we want to look at is how to balance an equation that has radicals. So when you look at this equation, you'll notice that one radical is appearing on both sides. What is this radical? You can see SO4 is appearing on both sides. So what best you do is to make an assumption. So you simply say, let X be equal to SO4. So what do you simply do now? You are simply saying, where there is SO4, I'll put X there. So I'll have 2X plus, giving me an X there, plus H2O. Now, why have you made this assumption? You have made this assumption to help you not get confused when it comes to the oxygen atoms. So after you do this, you now list down the atoms that are on both sides. So on the left side, we now have hydrogen atom, we have X, we also have sodium and oxygen. On the right side, we have hydrogen, we have X, we have sodium and oxygen. So you now assign numbers to each atom. You notice that we have 2 and 1 here, that is 3 hydrogens. We have 1 X, we have 1 sodium and 1 oxygen. This other side, we have 2 hydrogens, we have 1 X, we also have 2 sodiums and 1 oxygen. So after you do this, you now try to look at which atoms are not balancing. So you will notice that hydrogen is not balancing. Also, sodium is not balancing. Now, as we have said in the first example, when you notice that this atom is not balancing and the numbers are even and odd numbers, try to swap them. So let's try with a sodium. We'll say, because we have 2 here, we'll multiply this side by 2, then we multiply this side by 1. If you do this, we'll get the overall of 2 and the overall of 2. So what does this mean? This multiplying factor that we have used will be tentatively introduced on the equation that we have. So we'll put a 2 there, then with this one, because we are multiplying it by 1, we are not going to represent any number there. So what will happen? This introduction of 2 here has an impact on oxygen and hydrogen. You'll notice that now we have 2 plus 2 hydrogens, that is giving us 4 hydrogens. We also have 2 oxygen atoms there. On the right side, nothing has happened yet. So what can we do to balance off these two atoms that have been affected? So you'll notice now that hydrogen is 4, oxygen is 2. So what can we do? For hydrogen, if we multiply it by 2, we'll get 4. Also oxygen, if we multiply it by 2, we'll get 2. So you'll notice there is a multiplying factor that has been introduced, which is 2. And the good part is, these two atoms are found in this molecule water. So you simply put a tentative number of 2 here. This is the multiplying factor that we have introduced there. Now, what do you notice after you do this? You notice that both the reactants and the products are now balancing. Remembering that X is SO4. You wanted not to confuse yourself with the radical. So we are simply getting it back to the equation. So we are saying you now have H2, then you put the SO4 back, plus 2 sodium hydroxide, then you get sodium sulfate and 2 of water there. So if you look at this equation, it is now balanced. All the atoms are balanced. Hence, we can simply say this equation is balanced.